Okay, so oops. Build a set K. So. Does that look right? Set L. True. True. False. Looks pretty good. Who's got that one? This one here on the optic poly lens. It's really hard, eh? Oops. So hard I can't type it. Did you get your product out? You got it? Yeah. Good on ya. Cool. Yep. Say again? Yeah. There was one here. It's gone though. Yeah, I mean, have you written that? No. Oh, right. Apparently it can be done. Alright, so I've not done it before, so I'll give it a go. Alright, so the thing that goes there is an FTR, right? That's my goal. and the type of P. I can get the type of P with a little bit of trickery. Type of A is SQ to pair. Oh, hang on, is it? A is of type S. C is of type Q. K1 is of type A to FB to S to FT. K2 is of type C to FD to Q to FR. Okay, so that looks, I think that's right. So usually when I have a pretty difficult puzzle like this, I write out the types of the things I have and the type of the thing that I need. Alright, so these are the type of the things I have, this is the type of the thing that I need. And so I think the solution is around there somewhere. Has anyone written without the alongside data types? Okay. That can't be right. Oh, maybe that is right. Yeah. You mean that, right? So, what do I need here? That. C to TD. What? C to the pair TD. No, that doesn't seem like the right way. Sorry?
Oh, so it's not A and C.
I'm not sure what you mean.
Line 37, it's not A and C, it's S and Q.
Yeah. Here. Here you mean?
No.
This should be called S and Q. Yeah, I agree. Well, I'm starting to not believe that it's possible. And that the solution that I saw before had a mistake because I didn't check it. So no one's done it, right? So we don't even know for sure that it works. Just want to check that. Okay. The only other way. So the problem is one of the F maps you won't be able to do, and that depends on the order in which you do them. So if I swap them around, does that look doable? Oh, that's not right. K1 S. No. That's an R. Right, so if it is any way around, it has to be that one. Does that look about right? I think so. How does this go again? Oops. That's all right. It's all coming back to me. Actually, I don't quite like that. I like that a bit better. It's just patterns, right? So you know the lift A. Who doesn't know the lift A2 function? So basically, the lift A2 function takes a raw function a to b to c and returns a function a to b to c that's wrapped in the applicative functor f. But there's a really key thing about lift A2, which is if you compose it with itself, you get back another lift A2. Right? That is exactly the same signature, where f has combined with yet another applicative functor. And that goes on and on and on. And the pattern to see there is we're passing an argument and then an argument, right? So that's t arrow and then t arrow again for a different t, which is why that works, right? So that's given an argument and then given yet another argument. So if we ask for, say, the type of this function here, how many arguments does bool take? Who was at the intro thing yesterday? Who was here who was in the intro thing? Yeah, okay. So how many arguments does this function take? Correct. All functions take one argument. That's true as well, yeah.
Why do you need to call it?
So, well, if you call it, so let's just look at lift A2, right? And same for, this is true for fmap as well. This is threading an argument through here and then here. That's only one argument though, right? So when I do this, it's yet another argument that we're threading through.
Yeah, but can be that f equals f and then.
Yeah, so the applicative through that we're using is the composition of those two, right?
Yeah, but then why some people use one?
Why can't we just use one?
Yeah.
Because we have to be clear about, I mean, we essentially are just using one, and it's this one, right? It's the one that passes through one context and then another one, right? So because of the way lift A2 works, it's not going to work on these raw type constructors being composed like that. Like it's not going to work out that it's not going to work out that it's going to compose those two and then just only use that one. It's only going to use that outer one in the raw form. All right. Alternatively, we could write a data type like this, right, which goes like this, and then instance applicative for that. All right, so it'll be, so given the applicative for f and g, we can get the applicative, the composition of f and g, and also the functor, right? Then we'd have to wrap it up, call lift A2 once, and then unwrap it again. But this will work. So since we know that bool takes one argument, and we know these two bits of information, then And when we slot that argument, that function there into there, it'll be A to bool to A, right? There it is there. So all I need to do now is pass in a function that takes one argument, returning a function to take one more argument, which is what that does. Then that. Then I pass in the key, and then this is the set argument. So the key, then the set. And then the Boolean, actually. Yeah. But it all works out, and you can see that it works out because, so there's another pattern, right? The pattern looks like this, which is if you see, let me just think about it for a minute. If you see f of g of x of h of x, then this is lift A2, f, g, h. Right? So I took this expression here, noting that it was of this form, where that's f, that's g, and that's x. So there's sort of an intermediate step, I guess. I'll put that one in, which was lift A2. Right, so f, g, bool, set.delete k, set.insert k, SB, is that right? Okay, and then there was a next step, which was getting rid of those. And then once I've done that, I see that I still have an expression of that form. Right, I still do. Here it is here. There's f, there's g, and there's h, which is how I then get to this bit here. So that's why that works. It's just recognizing this pattern as soon as you see that. Yeah, good question, isn't it? Yeah. Yeah, I probably should. I mean, I get asked how you do this, and the answer is practice. There's no other way. And I guess I don't think there's any one person who holds all the patterns. Alright, so you're always learning different ones. So that would be a good idea, actually, yeah. I mean, these are just trivial ones. Yeah. Yeah, like I'm kind of doing these kinds of things off to the side, these program refactorings, and maybe I should write them down. And I've written some down, but not all of them. Yeah. Pardon? So you thought that was easier to read? Yeah. I don't have a position on that. I don't know. Well, so the counter argument though is that I can really see what's going on now. Like, so, you know what I mean? So if you had this embedded in your head, then you would also really see what was going on. But I don't hold that position. If you just find one easier, then just write it that way. So I tend not to care about that. I do care that I have the capability to do that, right? So if we were doing not functional programming, right, and lift A2 modified the XML file, or whatever it is happens at your work, then yes, the program just changed, right? So as long as I have that capability, that's all I care about. I don't care about the end result.
I think two problems. Just normal programming. You know, there are things there that can be extractable patterns. You can't find them because of math by all the letters.
Yeah, I completely agree. Yeah. So, and yeah, if you're not doing functional programming, right? If you're putting even just one variable somewhere, this ability just goes out the window. So yeah. But you know, if you memorize things, I mean, there's another pattern here which I think is important, which is once you know that lift A2 composed with itself is also lift A2. You memorize this, and you know the same is true for many things. Folder.folder is folder. That's not quite right, is it? It's folder fz.folder. Yeah, so the better one is traverse. So the type of traverse, right? Then when I compose it with itself, I get yet another traverse. If I lift the type of lift A2, so by another little bit of theory, I know that lift A2 and spaceship have the same amount of power, so they have the same ability. So lift A2 spaceship is also spaceship. All right, so all that does is turn F into the composition of these two. And I know that fmap composed with fmap is also fmap. So yeah, it's memorizing those kinds of things. Two functors give you a functor under composition, and so on. Yeah. Yep. Yep. Yeah, so the operators like, what is it, like this one, maybe? Yeah, let me have a look at some of my code. Yeah, okay. I need to get that over to that machine somehow. Hey? Yeah. Telepathy IP, right? Yeah, how can I do that? Suppose I can use my email address. look away, turn the camera off. Hang on. This is going to go good. Oh, it's 18 meg. Ah, you'll live. Okay. Alright, we'll get that in a sec. Hey. Yeah, I don't know the answer to this question. It says 6.
Yeah, it's on the poster it says 6. I mean, it's out. I think the keynote is 5:30.
The poster says 6:30, doesn't it?
When it's over, it's just,
Pardon?
the keynote's over at 6:00.
Okay. Well, I guess we'll finish up in 15 minutes.
Yeah.
Is that right?
Yeah.
Okay. Yeah, so I'm happy to go through things like, let's look at this stuff, right? Let's see if this works on a Mac, right? Surely. Okay. So to give you a bit of a background, one of the regulations in aviation is you must have a pilot logbook, and this is my opinion right here. CASR is the Civil Aviation Safety Regulations. In Australia, you have, I think they're called FARs here in America. And my opinion is that if you are a responsible pilot, you must use Haskell data types for your logbook. Well, you must. Either that or you're irresponsible. And I have this sort of a little bit of a hobby of mine is going onto the pilot forums and looking at all the problems that everyone's having about their logbooks, and it's quite hilarious. Yeah. People sharing Excel spreadsheets and, So my argument is that, there's certain things like, if you're doing, flight instruction, then there's going to be a flight instructor on board, for example, and if there's not, then there may or may not be. So all of these things I put in types. I've basically taken the Civil Aviation Safety Regulation that pertains to logbooks and tried to write them in Haskell types, and just said this is what a logbook looks like. And given that, it's quite a detailed tree of structure. Right? There's a lot of things to consider in a logbook. You know, like there is paper, right? That's a paper logbook. There's fields along here. There's things like, you know, for example, I could fill out that at the same time that I was flying a single engine aeroplane, I was also flying a twin engine aeroplane. Now, of course, that's a type error, right? I cannot possibly be doing that. For example. Yeah, so given that, here is an example of a query, right? So in Australia, you have what's called an aviation reference number. And this is a lens operator here. And if I remember rightly, that lens operator does a get. It's similar to doing a get through, yeah, what is it? It's get, right. Yeah, it's a get from what's called a getter. We looked at, I think you might have seen that on the diagram. So basically, dig down through the logbook to get through to the actual ARN. So through the logbook itself, then to the person who owns it, to the ARN, and then get the list of digits that describes that ARN. And all it does is just print it out. So this is a simple example of composing all the lenses together, and a prism in this case. Actually, this little function here, this RE function, is a lens function. It's built into the lens library. And what it does is it turns a prism around, so a prism AB turns it around to a getter BA. Right, so there's actually a getter underneath a prism. So it turns it around into a getter, composes a getter, so the getter being RE digit list, a lens, and then I think that's also a lens, which when you compose all of those gives you a lens, and then I say get from my logbook, that's the one I've written, my value of type logbook, and it prints out that. So that's a trivial example. If you've ever been into aviation, you'll know that it's you know, very heavily regulated. You get all sorts of crazy requests, and my goal here is to be able to meet them on demand. All right. So if someone says to me, "Hey, change your ARN from a 2 to a 5," for some bizarre reason, and bizarre reasons are fine because it's aviation, then I'm just going to quickly bang out that bit of code and say no problem. Whereas, you know, the paper person's going to get white out or whatever they're going to do. Yeah. If anyone, the pilot, has a logbook, you've got white out in there, right? Yeah. So over is similar to modify. So basically, go into the logbook, into the person who owns the logbook, to their surname, then go through each character and turn it to uppercase. And that returns me a function from logbook to logbook. And I like these things being first-class values, right? I can just pass this function around that will do this to your logbook or whatever it might be. And getting into a bit more detail, I might get audited one day by our regulator. It says, "Hey, what aircraft have you flown?" And what a paper pilot does, and by that I mean, I know these people. They sit there with a pen and paper and they go through each flight and transcribe it onto a bit of paper and say, "There you are." And I say, "No, I don't do that. I take this program and I say, there you go." So basically this one goes into my logbook, the one I own, into each entry, so that, you know, entries can be flights or simulator flights or whatever they might be. Wrapped is a function that unwraps and wraps an isomorphism. So, you know, remember isomorphisms can go both ways. So that wrapped function does that. Folded means the function that I'm about to give you, run it across everything in the list that's about to come up. And this here is a prism, and that says if the constructor in the entry is an aircraft flight entry, right? So there's like data entry equals, and then a list of different types of entries. One of them is a flight, an actual flight. And then once you get that flight, get the aircraft out of that flight. And that whole thing gives me a list of aircraft. All right? So basically I'd like to be able to take this little bit of code here and call it the day I get audited about all the different aircraft that I've flown before. And then when I get pulled up, it doesn't take me 3 hours to go through my logbook. I just run this function and say, there you go, Mr. Regulator. It's a little bit, fanciful thinking, but, hasn't ever happened.
Is there an application that is used by the people who report it?
Sorry?
Who's reporting information? Is it
Oh, I just mean, so if I get audited, right? So I go to the airport, I'm about to go flying, and I get audited, and I get this bizarre request.
Yeah.
And it gets much more bizarre than, show me all the aircraft you've flown before. What I do not want to do is go through a detailed piece of paper,
Right.
ignore all the bits that have nothing to do with aircraft, right? And then go through and go, oh, that one was not actually an aircraft, that was a simulator, and then transcribe that on. This is what actually happens. Transcribe it onto a bit of paper.
Is this specifically for you or for other people?
It's open source. You're welcome to use it. Yeah, but it's an Australian regulation. I've tried to meet the Australian regulations. So my goal is to get, in this case, Australian regulation compliant logbooks into a data structure, and then write lenses and so on over that data structure, so that no matter how bizarre the request you give me, I'm able to just zip it out. Because if you ever do go to an airport, especially in general aviation, I'm sure you will find people sitting at desks with pens doing these things that are otherwise automatable. And when I go to the airport, that drives me nuts. And it just motivates me to write this code. However crazy it seems, but I refuse to do that. Another example is there's a document published approximately every 3 months, which gives things like runway distances and things you'd be interested in. There's a mountain at the end of this runway and so on. It's a 1,600 page document, and what happens is, I found this out at one of the flight schools I was at, is that the flight instructors sit down every 3 months and manually diff those two documents. And that I just said, you do what? So they sit there and they take the two documents 3 months ago and today, and they go, oh yeah, that's the same. And I said, I'm not going to do that. So I don't.
Do you have, I guess my question was, do you have other pilots using this?
Oh, no. I do have people who have asked, but people who have never used Haskell before. Because they know that I do this, and they don't quite know how to do it, because they're not programmers, they're pilots, professional pilots. And they feel the pain, and they want to get out of the pain. But I say, you're welcome to use it, and I'm happy to help you learn Haskell and so on, but this is how you get there. So I hope my answer to your question will soon be yes, but at the moment it's no, it's just me. Yeah, I mean, if I went to the flight school right now and I said to someone, hey, can you show me the first flight in your aircraft with that registration? This will be a linear search through the paper logbook, right? That's what it's going to be. And it may get all the way to the end and they'll say, oh, I've never been in that aircraft, right? And I just refuse to do these things, right? These are automatable things. But the point is I have lenses that do that for me, and prisms in this case. All right, so go through my logbook. In folded, this lm of here is also another lens function. So that basically says that's the same thing as saying go through there and find me the first one of as you're doing this fold operation here. That's also a lens function. And that's why it comes back with a maybe aircraft flight, because I may have never been in that aircraft. Yeah. So you put your exam results in there as well. It may not be a flight, might be an exam result. And that's a common request. How many total hours have you had as pilot in command? Well, if I go and ask someone that right now, they're going to go through with a pen and paper and go, oh, that one, then add it all up and so on. I refuse to do this. Give me lenses, please. Yeah, so we distinguish between day and night in Australia in terms of hours. There's a requirement, 61.365, that so the Australian regulation says you're allowed to use electronic logbooks as long as if someone asks you for that logbook in paper format, you are able to provide that immediately. And so I have a function to do that. There you are. And I want to get extremely stupid, right? I want the most bizarre thing to be asked and still be able to answer it. And yeah, I've never been asked this, of course, but I want to be able to answer it. And I have written a lens for that, right? So my point is I have these first-class values, and no matter how bizarre you get, and as I learn more about aviation, I learn more about the bizarreness, I'm still going to be able to answer your question. Because the last thing I want to do is sit in an airport all day doing pen and paper, automated tasks. Yeah. So hopefully that gives you an example of, an application that gets used, but it's still only being used by me. Does that help? Cool. I do, yeah. I do keep paper. The reason is because those data types, I'm an inexperienced pilot, and as I read the regulations, I know that I've still got it wrong at any one time. And then I go, oh no, that bit, that's the bit I got wrong, and I have to change it all. And so for that reason, I also keep paper until I can it's in prototype stage essentially. Until I can nail it all down, then I'll throw the bit of paper in the bin. Yeah. So.
I've had lots of friends over the years keep electronic things in Excel.
Yeah. Well.
And they just, I see them 5 years later, hey, how's that logbook? Oh, I lost it, or, my hard drive died.
Hang on, that's the wrong way.
Some of my most important documents that I have in my possession.
Oh yeah, here we go. So this is the regulation here, right? So Casimir director, holder of a pilot license. Within if it's held in electronic form, produces a printed copy, right? And so this is what happens next, right? Which is, hey everyone, this is the CPL here. He's saying, hey, I'm trying to go digital on a budget. What's everyone using? I mean, I'm not going to answer this question. No way. This person's prepared to pay money. This person here uses an Excel spreadsheet on Dropbox. Not cool. Apparently there's some software called this. I don't like proprietary software, by the way. This person's expensive proprietary software doesn't do syncing very well. This person's proprietary software stops working when they cross the date line. This person here, it's free up to the moment you accidentally delete it and then discover there was no backups. So yeah, my logbook's in Git, written in Haskell. So I hope I never lose it. It's cloned in a few places. It's got to be a pretty big war till I lose my logbook. Yeah. So I hope that helped everyone. So I'm exhausted from yesterday. For those of you who turned up yesterday, so sorry if it appeared that way, but I am. And if you do get questions about this kind of programming with lenses and so on, certainly I'm able to help you and answer your questions. And there's actually whole forums of there's actually an IRC channel dedicated to the lens library, and it's got about 200 people in it or something like that. So it's quite often that you might be programming away and you think, how do I do this particular operation? It should be there, but I can't quite figure it out. And someone will have had that problem before and know straight off the top of their head what the answer is, and so that kind of business goes on. So.
One question.
Mm-hmm.
You have, for the course yesterday, you have solutions in your repository.
Yeah, I have my solutions there, yeah.
But not for the lens, right?
Yeah?
Is it with solution?
Yeah, under my account it is. Yeah. Yeah. Pretty sure. So yeah, send us questions if you get any. And use Lens when you're using Haskell. Save yourself writing code over and over again.